On.
Hi, I'm Jessica Elliott, and this is day 2 of my 5-day lesson plan, and it is about global warming and our carbon footprint. So to start out, we're going to look at our essential question for the day, which is, what do polar bears have to do with unplugging my phone charger? And in order to give us a little context, we're going to start by watching a video. So let's just keep this essential question in the back of our minds because we're going to come back to it later in the day. So here's a quick video narrated by Jeff Corwin, and it talks about the impact of climate change on polar bears. So it's about a 2-minute video. And then after the video, I'm going to have students take out their Cornell notes and write at the top the topic, climate change, and the essential question, how do changing levels of carbon dioxide affect Earth? And after giving them a couple minutes to write those the topic and essential question down, we're going to jump from our context of polar bears and then talk about how we got here. So what is the history of global climate change? So to start with, Earth has gone through cycles of glacial and interglacial periods. So a glacial period is when there's a lot of polar and mountain ice sheets that are pretty extensive and go over the sea. And then interglacial periods, if you break down that word, inter is between and glacial is what we just talked about. So interglacial periods are warmer periods that are in between the glacial periods. And most of Earth's history has actually been characterized by more humid and hotter climates than what we're experiencing today. And scientists believe that for about the last 10,000 years, we have been in an interglacial period. So this graph right here shows the last 1500-ish years, so within that interglacial period that we're currently experiencing. And it gives different averages, global averages that have been calculated from different locations on Earth of temperature. And so you can see that the temperature does fluctuate a little bit. A couple things that I want to point out are this medieval warm period right here. So looking at that, I'm going to ask students what they notice, and hopefully they will answer that they notice that the temperatures, average temperatures, are a little bit higher than most of the graph. And then I'm going to ask them also what they notice about this little ice age, in which hopefully they will respond that they see that there is a temperature dip where temperatures are lower than average on most of this graph. And then finally, the last takeaway that we want to look at is what we're experiencing right now, which is these super high levels of CO2, which is causing a higher temperature even than the medieval warm period. So even within this interglacial period, there are times of warm and times of cool, but right now we are experiencing warmer than even the warmest time on this graph, which is the medieval warm period. Okay. So what are some causes of long-term climate change? Well, there are a few different things. First of all, there are changes in the energy produced by the sun. So there are magnetic storms that are called sunspots on the sun. And when there's higher solar radiation during times of those sunspots, there's also higher temperatures. And when there's fewer sunspots, then temperatures are generally lower. So that's one thing. Another factor is the position of continents. So when all of the continents were pushed together in Pangaea, there were different ocean currents, and it was more difficult for the oceans to move heat in an equal pattern. But now that the continents are a little more spread out, oceans can go between the continents and distribute heat more evenly. Another factor is the tilt of Earth's axis and orbit around the sun. So those are all factors that are in cycles that last on the order of hundreds of thousands or thousands of years, up to 100,000 years, depending on which factor you're looking at. Catastrophic events such as the asteroid impact are things that can cause mass extinctions due to the climate changes that they produce. And finally, greenhouse gases in the atmosphere are a huge contributor to climate change over long periods of time, and that's where we're going to focus the rest of our lesson. So, what are greenhouse gases? Greenhouse gases trap heat that radiates off of the Earth's surface. So, if we look, let's go back. If we look at this graph right here, we can see that these greenhouse gases are right around the Earth's surface. And as solar energy is coming into the Earth, some of it is absorbed by the Earth, but a lot of it is reflected or radiated off of the surface. And of that radiated heat, a little bit goes all the way out to space and escapes, but most of it is trapped here by the greenhouse gases. So before I show the second bullet point, I'm going to ask students what they think will happen to temperature if greenhouse gases increase. And I'm going to have them discuss that in their small groups of 4. So after they discuss, we'll come back and get to the main point, which is that an increase in atmospheric greenhouse gases is going to increase global temperature because that heat is trapped by the gases. Here are some examples of greenhouse gases: water vapor, carbon dioxide, methane, which is commonly produced from livestock and agriculture, and then nitrous oxide, which is usually a result of fertilizers. So let's talk a little bit more about carbon dioxide. Some processes that add carbon dioxide to the atmosphere are things like volcanic eruption or decay of burning organic material. So decay is like rotting, decomposing of plants and animals that contain carbon dioxide within their material. Some processes that remove carbon dioxide from the atmosphere are absorption by those same plants and animal tissues while they're alive. So here's a little picture of a tree, and it's using this carbon dioxide and producing oxygen. So that would be considered a carbon dioxide sink because it's taking that carbon dioxide out of the atmosphere. So carbon dioxide levels have fluctuated, so gone up and down over time. However, in the last 650,000 years, the atmospheric carbon dioxide levels have never surpassed or gone over 200 parts per million until now. As of last week, the current atmospheric carbon dioxide level is 408.11 parts per million. So parts per million is a unit of measurement that explains concentration. So if a percent is 1 part out of 100, part per million is the same thing, just a much smaller concentration, and it's 1 part out of 1 million instead of out of 100. So even though it is a very small portion of the overall atmosphere, what's important is the relative concentration. So up until recently, we had never gone over 200 parts per million, and now the global average is over 400 parts per million. So that's more than double what it has been in the last 650,000 years. So why do we think that carbon dioxide levels are increasing? And this is something that I'm going to ask the students to discuss in their small groups before going over a couple examples. So after they discuss, we'll talk about burning fossil fuels, which contain carbon dioxide. And just a reminder that plant and animal tissues contain carbon. So fossil fuels are those fossils that were created by plant and animal tissue. So burning those fuels releases carbon dioxide. Here are some examples: transportation, producing plastics, power plants, heating and cooling our houses, and factories are all different examples of burning fossil fuels. And also deforestation is another way that we can increase CO2 levels in our atmosphere by taking away all of those trees that were using the carbon to give us oxygen instead. And as the next part of our lesson, we're going to do an activity where all of the students are going to have the opportunity to calculate their carbon footprint. And so that's where I'm going to end for now.